Okay, this video is about electronegativity and covalent bonds. We talked about electronegativity, the ability for a nucleus to pull on an atom, and that explains some of the unique characteristics of covalent bonds. Unlike ionic bonds, which have to occur between a cation and an anion, and so the tendency is to occur between a nonmetal and a metal, covalent bonds can occur only between nonmetals, and this is a little weird, but it has to do with electronegativity. If oxygen is coming along and we have it paired up with carbon, well, instead of what it does with lithium, by pulling the electron completely away, carbon still has an appreciable pull on that electron, and carbon doesn't want to let it go. So the oxygen and the carbon come to this sort of compromise, and that electron spends some time with oxygen and sometimes with carbon, and that has some consequences. We know that electrons continually move. They're attracted to the nuclei because opposites attract, and they repel each other because like charges repel. So now, that complicated dance that electrons are doing, they're no longer doing that with around just one nucleus. They're now doing that around two nuclei. So you've got an electron, and it's spending some time over here with oxygen, and then it's spending some time over here with hydrogen, and it's floating around and zigzagging, and you've got other electrons that are trying to get in and out of its way, and so you end up changing the orbital, and what you create is a hybrid orbital. You create a hybrid cloud that surrounds both of the nuclei. So in ionic bonds, when honestly they are just magnetically attracted to each other due to electromagnetic forces, there's nothing literally binding them to each other than the fundamental forces of the universe. In covalent bonds, you do have something that is binding them together. You've got two nuclei trapped around this now crazy, super big hybrid orbital binding them together. So that is a different interaction. And that only occurs because that carbon is not, the carbon's pull is strong enough not to relinquish that electron completely to oxygen. So there you have it. You've got a covalent bond. Now, unfortunately, not all covalent bonds are the same. We divide them into two further categories, and those are nonpolar covalent bonds and polar covalent bonds. So polarity has to do with charges. If a charge is present, we call it polar. If a charge is not present, it's not polar. So what does that mean for covalent bonds? Well, if you have two atoms that have either the exact electronegativity or electronegativities that are very, very close to each other, so that there's no clear winner as to who's pulling on what electrons, then you have nonpolar covalent bonds. And that means that the electrons spend an equal amount of time around every atom. They don't show favorites. There's no place where there's usually more electrons or usually fewer. They share equally all the time, or most of the time. Whereas, if you have two atoms that have highly different electronegativities, they may still be sharing, because it's not far enough to rip electrons apart from each other, but it's still pretty far. Well, then the electrons are going to spend more of their time around the atom that has the stronger electronegativity, because that means they have the stronger pull. So when oxygen is paired with phosphorus, or oxygen is paired with carbon, oxygen is going to have a higher density of electrons around it at any given moment compared to the carbon. That means that side of the atom with a higher electronegativity is going to have a partial negative charge, because electrons are more likely to be there. And the side of the atom that has a lower electronegativity is going to have a partial positive charge. So now this molecule that is covalently bound has regions of slight charges, and that means the molecule is polar, and the molecule will now exhibit the properties of a polar molecule. That doesn't happen when electrons are shared evenly. There's no polarity. And polarity influences how molecules interact with each other, and that is important for how biological systems work and how cells and biological molecules are formed. We will talk more about polarity soon. I hope this helps. Struggle well.